What's up? What's up, everybody? Daniel here, and yeah, we're gonna work on Jackscript. I worked on it this morning, and yeah, I did a little bit of work. Oh, tags are releases, I guess. And yeah, I just did a little bit of coding, but nothing too intense. I want to work on it now. I'm gonna get rid of all these. Um, Wait, I'm lying. I didn't work on it this morning. This morning I was working on something else. Um, I worked on it last night. And I was editing the documentation last night as well. I'll show you. Documentation looks a little bit different. And I'm having coffee, and I know it's 6:40 p.m. But it's a Monday, so it's justified, right? So this is the new documentation. Obviously, if you go on npm node package manager, the documentation is not yet updated. The documentation is not yet updated. As you can see, this is the old documentation, as you can see, as compared to this one. And the reason for that is that when you're working on a library, for it to appear or for it to be updated on npm, you need to release it. You need to actually make a release. And I've worked on this thing 3 years ago. I don't even remember how we actually make a release, but it's a Google search away, so it's not a problem. So this is the new documentation about Jackscript, and this is a little summary. This is obviously the old stuff. Shows you how to install it, how coordinate, what coordinate is, the type, the relation type, and I just tell the user what this is, but I tell them that, hey, you can like read about this in the next section. And I tell them how to what a set is, and I mean how you can use the set by just calling a normal set in JavaScript. But then we introduce Jackscript here with the coordinate. That's how you import it, and then you instantiate your set, and then you can add, and then if you print it out, this is what you're gonna get. Or if you console log out the set, this is what you'll receive. And then I say the minor difference between set and Jackscript set is that the Jackscript method add and delete are a bit different, etc., etc. One thing that I need to change is when we get to here, because I say, and this is the core difference between set and Jackscript set, which is incorrect. There's a lot more that is different between normal JavaScript set and TypeScript set, or my Jackscript set. I go on to say that this is how you print your set, and you can print it out. You get 1, 2, 3 static methods. Yeah, static methods, intersects, union, domain, and range. So I just go through those here: domain, range, and intersects. I don't go through union. Oh, here I call out create Cartesian. I need to add more documentation. I think just above this, I need to write about creating a Cartesian, and I also need to explain the relation type. I mean, I did highlight it here. Actually, maybe I don't need to, but yeah, I'm not sure. But I will write about it right here, or write about the Cartesian, the create Cartesian method, and then is subset of and is superset of. I'm not sure if I should write about that because I actually need to re-implement these methods. It's just that well, actually, I think I did already do that. Let me just check. No functions. Yes, is subset and is superset. I actually did. Yeah, well, I could just leave it like this because they essentially do the same thing. Is subset and is superset are the same methods that you find in JavaScript. So this I don't think I need to like I don't know, just I don't think I need to explain it in the documentation how they work. I mean, yeah. Anyway, and then that's it. Everything here, everything from all functions going downwards needs to be eliminated, and I need to start from scratch. These are properties of relations. So this header here will say properties of relations, and I'll explain all the methods. These are the methods. These methods. These ones I already spoke of. Yeah, is relation method I've eliminated. And yeah. Okay, so where do we begin? Is let me not work on the documentation for now. Let me focus on working on the library. But if I work on the library, what do I work on? Do I work on the unit tests, or do I work on the actual library? I think I should just work on the library, man. Just get it done, you know? Just get it done, and then I'll come back to the unit tests, okay? And to get that done, then I need to reach to my book to for references. So where's the functions? Here it is. And then I'm gonna add more methods here. Now I need to add the properties of relations. Let me think, how am I gonna add those properties of relations? Do I add them in the same, and does, let me ask, okay, let me ask an LLM if I could write friend functions for classes in Java, in TypeScript. Can I write friend functions? Here's a different way you can implement something akin to a friend function in TypeScript using module level functions. TypeScript uses a module system where variables and functions declared in the same file are accessible to each other. You can use this to create functions that have access to private members of a class. So here we have a class, it's just a normal class. Here we have a function inside of the class which is public, and it's a friend function. This function can access private members of my class. Wait, oh, this is outside of the class, okay. And then I have instance my class, and I can say instance secret data. What is secret data? Okay. Const instance equals my class friend function. Okay, it's just way too okay. Okay, using a closure, you can define a function within the class, returns an object with methods that have access to private members. So get friend instance dot get friend is friend dot reveal secret. Reveal secret is the, oh, okay. Damn, I remember learning about closures 4, maybe even 5 years ago. Using TypeScript type system, you can use TypeScript's type system to create a type that represents a private structure of a class. Using shared private key. You know what? I think I'm just gonna stick to having everything in this one file. I'll just have everything in this one file. And I don't think it's that complex of a file. It really isn't. So I think it's less of a burden to have all the methods in here and this page go all the way to like line 300, then say have this type of stuff or like closures and stuff, you know, and have different files, etc. Rather just have everything here and just get rid of all these files here. Like I won't need to have this. As a matter of fact, I once implemented these functions, so I might just reuse these. Yeah, I'm just gonna delete this file, but just copy all the code. This may be a long video, so okay, it's gonna be a long video. Okay, where do I even begin? I don't even know where to begin. Is reflexive, returns a boolean. It's this. What is this? Convert relation set to an array and iterate over it. No. Is symmetric, is irreflexive, is reflexive, is reflexive, is irreflexive. Okay, so let me just copy this. In fact, let me just copy, no, let me copy this. Put you here. Wow, okay. Okay, let's think. Is reflexive, this is a method, so it's okay. So we're gonna be taking in a set. I'm gonna say the set, which is type Jackscript set type T, right? And this returns a boolean. Yeah, and we're just gonna keep going. Is irreflexive, well, is symmetric, is anti-symmetric. Yeah, is symmetric, is anti-symmetric. My coffee has gotten cold. Remember, symmetric, if a set is symmetric doesn't, if a set is not symmetric doesn't mean that it's anti-symmetric, and vice versa. Alright, is transitive, does it meet all the conditions for it to be transitive or not? And what is this? Oh, this is the function. Is transitive, is inverse relation. I don't know what that means. Oh, is it the inverse of the other? Okay. Let me think real quick. So a set and a set, Cartesian product of those two sets will return a different set, right? and that set is a relation, but it's a set. It's still a set. It's essentially still a set within itself. You could just present that set and say that this is a set. That set will be the relation of two sets, right? Yes, will be the relation of two sets. It's still a set. So let's just say we remove the okay, it'll be a set. Let's just say it's a Jackscript set of coordinates, which is a relation of the type relation. Remember, relation is a Jackscript set of coordinates or a Jackscript set. So essentially, let me just check this real quick. Coordinate. So essentially, anything that is a relation is still a Jackscript set, or it's a Jackscript set of coordinates. So if we have a set of coordinates or Jackscript set of coordinates, and I take that, and then I have another Jackscript set of coordinates, right? Now there's two Jackscript sets of coordinates, and then I create a Cartesian product between those two, then I'll get a relation, and a relation is a Jackscript set of coordinates. However, in this sense, it'll be a Jackscript set not of Jackscript sets, but of coordinates. It's just that you've basically merged two Jackscript sets of coordinates together. Anyway, let me write these methods, okay? So is transitive. Oh, okay. I'm gonna go heat up my coffee, and then I'm gonna grab my book. I'll be back in a second. Oh, sorry. Flippin' hell. So, let's see here. The Jackscript set of coordinates. Where did I write my stuff? Okay. Oh, there we go. Just like right there. Okay, I'm gonna start with the reflexive. So I need to reflect check. I wanna speed run this as quickly as I can. However, I'm just gonna have to make sure that I'm doing the correct things, right? this code needs to be eliminated, but I won't eliminate it just yet. I'm just gonna leave it. Is reflexive. So okay, it's a method. So let me just read what a reflexive is, because these things are not easy to retain. In order for some relation S to be reflexive on A, we should have 2, 3, 5. Oh. Okay, so properties of relations. So when I'm reading this, all of it always starts with let A equals to a set, right? And if, let's say, R, which is a relation on A, right, is equals to something like, it's always coordinates. So this is always the type of coordinate. So they always say if this is like this or whatever, or it doesn't matter what the values are. If R is a relation on A, meaning that R is a set of coordinates, it's always a set of coordinates, then you determine if R is transitive or is symmetric or is in antisymmetric, etc. But it's always a set of coordinates. So this is basically a Jackscript set of coordinates, type T, type B. Essentially, basically, that's what's happening. So that means that this always needs to be a Jackscript set of coordinates. It cannot be just a normal set. It means that it can either be, you can either pass in a relation. In fact, you can pass in a relation. No, but I'm just gonna leave it as this. But a relation also meets the conditions of this. I just don't know if what will happen if you pass in an actual Jackscript set of the type T, meaning you just pass in this, because this is also classified as a relation. So, and I've had this problem before, or I've not had this problem before. I've spoken, conceptualized, and I foresaw this problem before, and I'll just leave it as is. I'll just see what happens. I'll just code up the entire library, and then later on I'll just see if it's possible for me to actually eliminate this from being a relation. And if it gives me problems, I'll just leave it. If it doesn't, then I'm just gonna get rid of it and then retest the entire library. Okay, so yeah, is reflexive, needs to be a Jackscript set of coordinates, right? And now we're gonna test. So essentially, yeah, because it's a relation. Really, in theory, I should be passing in a relation here, but okay. In order, alright, so it says that in order for some relation S to be reflexive on A, we should have 2, 2, 3, 3, 5, 5. Okay, so let's just say this is 1, 2, 3. So A, which is my class here, or the instance of the class, the set, which is the internal set. If the values are 1, 2, and 3, then for this to return true, then whatever's passed in needs to have 1, 1, 2, 2, and 3, 3, basically. these should be in the set. You can have other elements, but they should be there. So, and obviously I had written these functions before, and let's just see what I had written. Where's my method? Is reflexive. Create auto repairs and check if they exist in the my coffee's gonna get cold. So let temp array equals this, let count is 0, main set for each, so main set for each e, let temp chord e. Create ordered pairs and check if they exist in the relation set. Oh, okay. Oh, nice. I see what they did there. Like I'm saying I see what they did, as though it wasn't me who wrote this, but I wrote this 3 years ago. Okay, I see what they did. So they created a coordinate with the values that are similar as the first and the second, and then they just checked if it existed in the relation set. That's a smart way of doing it. Okay, I need to make a loop. I need a loop, so I'm gonna say for each, or this dot for each, no, this I need to say internal set. Is it this dot internal set dot for each, right? And e will be my element lm, which is a type T. Let me just do this. What's wrong? Is it not of the type T? Argument of type lmt void is not assignable to parameter of type value t, value 2 t, set t void. These types of parameters lm and value are incompatible. I am confused. Let me just do this. Okay, maybe when I speak of the type T, they assume that I'm speaking about type T, which is like my internal set's type or my class's type, which is T, and I only have one type. They assume that I'm speaking about the same thing the same thing as this type that I have inside of this method here, and I am not. So now I'm definitely speaking about the type of my class. So anyway, this is internal set dot for each, which is the element console.log. Okay, but I'm not trying to log that out. I'm trying to do this. Wait, I'm not thinking. I want to loop through each element inside the internal set, and then each element I'm trying to create a coordinate, right? I'm trying to create a coordinate. test coordinate, well, I already did say what type it is. Test coordinate is equals to lm and lm. Okay, now we have type issues. This has to be the type of T because it comes from, yeah. Now we have it. We created this coordinate, and then now we need to check if it exists inside of the set. So I'm gonna say if the set dot intern oh sure. If the set dot internal set dot has test coordinate dot has what's wrong? Oh, wait, let me think. The relation that I'm passing in here will be of the type what? I mean, it needs to be of the same type, right? I mean, if I have a number, if I just have numbers in a set, right? As this is numbers, and then these coordinates also need to be numbers. It doesn't make sense for me to pass in a relation that is like a number and strings, or like type numbers, like as in like number string, but this is of the type, like, what am I doing? But this is of the type number. It doesn't make any sense. Wait. Wait, remember that a relation is A relation is two sets that merge and then become of different of coordinates, and coordinates can be different types. So confused, man. I'm confused. So let me think. Test coordinate, which is this, right? Test coordinate, which will be this. If this is the type number, which is t, right? I'm creating a new coordinate, which will be of the type t. Okay, let's just say of the type k, the type k. Oh, it won't accept it. Can't find k. Let's say it's of the type k. This dot internal set dot for each. This is of the type t, because internal set is of the type t. Now it says it's unrelated to t. Yes, you're wait. Let me just read that again. Argument of type element k void is not assignable to parameter of the type value t. Value t, you said t void, etc. No, you're right. That is correct. This needs to be t. No matter what, this needs to be t because I'm dealing with the set t. Because essentially I'm going to loop through the internal set of this. This internal set is of the value t, so it has to be t. It just has to be t. Okay, so of the lmt, and then we create a test coordinate. Test coordinate is equals to lm. We create this coordinate. Now if the set which is this one dot has, right, test coordinate, which is this coordinate of type t, argument of type tt is not assignable to parameter of the type coordinate pv. It's not assignable to this. What? What does that mean? I mean, if I remove this and say any, then all is good. But I need to think. This set, the set dot has, the set is of what type? The set that I'm gonna pass here, I need to pass in a type that makes sense. It's gonna be a JavaScript of type what? I mean, relation of type t requires 2 arguments. Where relation requires 2 arguments? Relation require, okay. Well, it makes sense to be TV, no? Oh man, I can understand. So a set can have different types. So a set can have a string, can be a number, can be... I don't know if that solves my problem. I don't know if me discovering that solves my problem or makes it worse. But because a set can have different types, then flippin' hell. This just complicates things completely. I don't know, because I can have A as a number. I can also have let B as a number or a string, and I can have something like 1AC, something like that, you know. Oh my god. I don't know what to do. I'm confused. Okay, let me just start from the surface level. My sets, or at least the Jackscript set. Okay, let's just do this actually. I want to test something out. A Jackscript set. This is a number. Can I say it's a number or a string? Set A. Okay, so I can do this. C. Let's just say string. Whatever. So I can do this. But now the problem comes when I do the Cartesian. Because now it says, oh, you can do that, sir. Set R is declared, but its value is never read. Wait. Type relation string number or a number is not assignable to type relation number. Okay, so the way this is created is that oh, there we go. Then if you were to do something like this, then you would also have to do something like this. Wow, okay. This is too confusing for me. I don't think I understand TypeScript enough to actually go through all that, but I mean, I understand how you need to do this in order for this to work. And I think it becomes it becomes infinitely complex the more you go into it. So I think in my case, let me see. I think I can. Okay, let me just try and sort it out. So we have a set here. It's a number. Right. I mean, you can do this, but let me not think about this, because if you want to do something like this, you're going to have to manipulate your sets like this in order for it to give you the outcome that you require or you desire. In my case, I'm just gonna build this how I think it should, as long as it works. And I think you can manipulate it to make it work however you want it to work. So if is reflexive, right, is a method. Takes in what type? Let me leave that alone for now. Takes in a set, right? Is reflexive, you're testing, you're passing in basically a relation or a Jackscript set of coordinates. And that Jackscript set of coordinates, you're going to try and loop through your own internal set and check if your elements a or like 1 which is 1 and 1, if they exist, and that's a coordinate, if it exists in your Jackscript set of coordinates. Coordinate any. I mean, the coordinate should have at least be of the type T, and then any. Can be V, because you can't choose what type of coordinate that they pass in. It could be of T, which makes sense because it's of the same type as the initial set or the set that you're testing, the reflexivity, if that's the word, to or of, and then any other type, right? That makes sense. Okay, let me try and explain this just so that I know I understand it. The reason why this works, and I could have also have said relation here. No? relation doesn't work because Jackscript doesn't work. Wait, what's going on? This doesn't work. Jackscript set. This doesn't work. So if this doesn't work, relation won't work. Wait. Yeah, it won't work because Jackscript is this. If Jackscript.ts doesn't work, Jackscript set T doesn't work, then relation won't work. I told you time and time again that. Okay. Anyway, Jackscript set of the type coordinate of type T and any. So let me explain why this works. This works because Jackscript set of coordinates. So now the internal set, this dot internal set, which is this class, right? Which we're talking about our internal set. We're gonna loop through it. So this is it. This is our class. This is our set, right? We're gonna loop, and this is of the type number or T. And if I say 1, then this is 1 1. These are numbers, number. And I create, this is a number. And then if I go into this if statement, if the set, which is this thing here, the argument or the parameter, has test coordinate. If it has test coordinate, which this, and what is test coordinate? Test coordinate is a coordinate of number. If it has it, okay, so why does it allow me to pass it in? It allows me because if I have T and any, because, or any because I'll have T here, and I could have also used any because T is associated with this type of the class. It's T is obviously, it's T, it's all around here. It's the type of the set. It's the type of the set of the class, right? So it corresponds with the type of the actual class, because this is of the type T. It's a number. This is a number in this case. In this case, this is a number. Now the second type, we don't know what it is, so we can't pass it in. We can't say, because if we have V here or U or whatever, then you're essentially telling it that, yeah, we know what type you have or what type you associate with. Like this, the other type will be a string, essentially, but we don't know that for sure. We don't know that there are strings in here. So when you pass this thing in, we don't know that the guy who instantiated the class did something like this, or if they did something like this, like number string. We don't know that. We don't know that beforehand. So that's why we have to pass in any. So an any could be string, number, boolean, whatever. So this makes sense. Maybe I don't know how to explain it properly, but it definitely makes sense in my head. Okay, and if it has test coordinate, well, if it doesn't have test coordinate, then return false. Otherwise, return true at the end of it all. Okay, so now let me test irreflexive. For this to hold, none should show up. Okay, so it's basically the opposite of this. Let me copy this, paste it here. Let me copy all this. If let me do, so this dot internal set dot for each let me think, none should show up. So if the set this, okay, we're looping through, so none should show up. Wait, let me just go back to is reflexive. Is reflexive says that all pairs should show up, and we're looping through all these elements. This one, if now we go to this one, the first element, which is 1, this dot internal set dot for each, so we're looping through it 1, so this is 1 1. If the set dot has, if it doesn't have this, return for. Okay, so let's say it has 1 1, it moves on, loops again. 2 2, it has it, it doesn't say false. 3 3, it has it, it doesn't say false, and then it's done, and then it will return true. Great, so that makes sense. Is irreflexive means that it should have none. So if it goes and finds 1 1, right, if the set dot has 1 1, then return false. If it goes through it 1 1 2 2 3 3 and they all are not there, then it will return true. So I just needed to remove that negative what is it called, component of the if statement, make it true. Yeah, that should work. And yeah, maybe I should test these things first. Okay, how do we test these? So there's a lot of shit going on here. Let's just say set A. Okay, test new Jackscript set of coordinates number. My array is a coordinate number, and I want to have 1 1 2 2. I should have tests of these things here, but okay, it's fine. 1 1 2 2 3 3, because I'm going to be testing set A and set A. Oh, what the hell is going on here? Okay, I'm going to test n set A. Oh no, never mind. 1 1 2 2 set A dot add 1 2 and 6. I'm gonna have 1 1 2 2 and 6 6. 1 1 2 2 and 6 6, and I'll get rid of you. And I'll test my array. So my array, for item of my array, test.add, I'm gonna add all these items in here. So test should be reflexive on set A. No, yes, on set A, yes. So now let me say console.log what is it, and set A dot is reflexive, and I'm gonna pause in test, and let's just see what we get. So how do we actually test that? cd documents, cd Jackscript, run dev. I should get true. It should be reflexive. Pause, we have an error. Nset A dot is reflexive on test. Nset A dot is reflexive is not a function. So what is nset A? Is of the, oh, okay, it's not a check. Oh, okay, this is confusing. Let's do this. Of the type number, and nset A does not exist on nset A because that is not a Jackscript set. It was a set. True. There. Nset A is reflexive on test, and console.log nset A dot is irreflexive on test should return false, and then we'll make it we'll make it irreflexive. Is irreflexive on test returns true. Wait. Okay. I made a mistake. So we have 1 1 1 2 and 6 6. So okay, it means that this first true is incorrect. Let's just make it 2 2 and see what exactly we get. Is in this case, how it should work is that now reflexive should return true, irreflexive should return false. But they all return true. True, true. Well, okay. Is reflexive returns true. Wait, I'm confused. One, two, three returns true. One, one, two, two, three, three. Okay. If the set dot has test coordinate and this is false, to properly test this I need to break it. Let's just say 0. So the set that has test coordinate let me run that again. It's supposed to break. False, false, false. Then what's going on? Return false. Why is it not breaking? I'm gonna ask this. Hopefully it doesn't give me the damn answer. Why is my code not breaking after reaching the false? The issue of your code is that you're using for each and trying to return from inside of it. However, return inside of for each callback doesn't break or return from the outer function. It only exits the current iteration of the for each loop. Here's how you can fix it. Oh, okay. I need to just use a for loop, not a for each loop. I'm not using a for each loop. Okay, so I'm gonna say for let lm, which let me just say any for now, of this dot internal set. I'm just gonna have all these things in here, and for let lm of this dot internal set. Yeah. Okay, so I think now it should work. Let's see. Okay, let's try it again. False true, so now we have a false. It said false true. Is it reflect? Okay, this is the same, so oh man. Oh, okay, never mind. I'll just change that. Okay, now let me run that again. It should still say false. I don't know about the second. Oh, it should say false and true, right? False true, false true. Now let's convert and actually have it say true false, because now it fits reflexive and it doesn't fit not irreflexive. False true. Now it says false true. Before it said false true, now it says false true. Okay, let's think about this. Is it reflexive or is it not reflexive? Because now it says false true. Okay, let's just one thing at a time. My array n set a 1 2 3 is reflexive, and we're passing in test. Test is this, which has these. And we're checking if it's reflexive. Is it reflexive? Is it true? Is it false? And our test case is 12266, and it says false, so it says it's not reflexive. Let me just check if I did the things correctly. For lm of this dot internal set, right? Test coordinates is lm and lm. I set test coordinates to this and this. let me just pass give, is this code proper? Yes, the code is a proper implementation of is reflexive method. Let's break it down. You don't have to break it down for me, brother. I know that it's correct. I'm joking, I didn't know. That's why I asked you, but I just wanted to check if everything is proper. Return false. Doesn't seem to return a false. Let's just see. Console.log. I have found a mismatch. Let me console.log lm will be lm. Oh man. And then and I'm not sure if this will be visible or will display on my console, because it might just say object. lm1, the set internal set is 1122. So 1 is not being found. Wow. So you're telling me that 1 is not equals to this? That's what it's saying. It's saying that this is not equals to this. Okay. I wanted to say I have found a mismatch and tell me if those are not. So it's false. Okay. So let's just see here. So this, just copy that out. Console.log my array 0 is equals to let call equals to this that I'm creating here, which is test coordinate. I'm creating a coordinate here. Let me get rid of this. is number cod. So let's see if you tell me if that's not the same. It's not the same. What? My array 0. What? Console.log my array 0 console.log my array 0 and console.log what is this? Cod. I just want to see what I get as the output. Am I getting the same thing? Is it 1111? Yes, but the types maybe are different. Maybe if I say type off, cod, type of cod. Maybe it's not 1111. Object, what? Let me just copy this and just ask Claude, why are these not the same? The issue you're encountering is due to the difference between array literals and tuple types in TypeScript. Let's break it down. Oh no, what? Wait, what? Your coordinate type is likely defined as a tuple type. Yes, it is a tuple. When you create array, you're using array literals. But they're of the type coordinate, which is a tuple. These array literals are inferred as number arrays. Type number, not as tuples. When you create cod, you're explicitly typing it as a coordinate. Yes, it is a coordinate. This is correctly inferred as a tuple. Yes, it is a tuple. The type of operator in JavaScript, which TypeScript uses at runtime, doesn't distinguish between arrays and tuples. It will return an object for both. To fix this and make them the same type, you can do one of the following. Use as to assert the type of the array literal in my array. So my array is type coordinate number equals to this as number array. What? What the fuck? What? To assert the type of array literals in my array. Okay, there's another option. Or create the array elements as explicit coordinate types. That's what I wanted to do. What? I have to do this? So that means that if I'm adding these values, let's say, because here I'm adding, oh god, no, this isn't, I mean, it's of the type, okay. Can't I just do it in one simple swoop, like here as I don't know, as coordinate or something? If you're using TypeScript 4 or later, then you can use the asConst assertion to make the literal tuples. as const. After making one of these changes, the type should be consistent. So this will make it tuples as const. I need to learn more about as, because I didn't know about this. What is it? Array. What is it called? Array literals. So there's a difference between array literals and tuples. I mean, yes, of course. I don't know, but apparently this will get the job done. So maybe let me go back. I mean, this returned the same thing. So wait. Okay, let's. This should be the same after adding as const. Let's run that again. So I should get true. I get false. But I get false. It's not working. Still false. Doesn't work. I mean, I am using TypeScript for later. What is TypeScript? Damn it. TypeScript version. TSC version 5. TypeScript 5. And I don't have TypeScript here. I'm using TypeScript 5. But I still get false. You're right. I apologize for the confusion. In my previous response, the issue here is more subtle and relates to how JavaScript and by extension TypeScript compares objects and arrays. Let's break it down. Even though my array 0 and code are both type coordinate number, they are separate objects in memory. When you use equals or equal, triple equals to compare arrays in JavaScript, it compares their references, not their context. So it's basically the same as in C++. Like, is a variable pointing to the same location in memory as the other one? Yeah, no, I understand. Since 0 and code are separate objects, even though they contain the same values, comparing them will always return false. I thought if I use the double will be true if it returns the same thing, but equals will return false if it's different or the different type. To properly compare these, you need to compare their contents. Here's how you can do that. Console.log my array 0 0 equals to code 0. What is code 0? Oh, their context. Oh my gosh, no way. And oh, this will compare the individual elements of tuples and should return true. Alternatively, you can create a helper function to compare these coordinates. Function coordinates equal of type T. Yeah, I think using a I need a helper function. Let me use this. I'm gonna copy this code, and now we have a helper function of which I'll plug into the functions. I'll just keep it somewhere here at the top. Coordinates equals, so we pass in the coordinates of type T and T. Okay, So let's just pass that in. Does it return? It just returns, so I need to still use console.log. Coordinate people. Someone is at the door. I need to leave, guys. I'll be back in a second. I'll be back in a second. Someone is at the door. Damn it, can I? Yo. So I've enlarged myself, man. I've enlarged myself in order for me to speak about what I want to speak about, man. Are you good, bro? Anyway, so I've taken a conscious decision to take a pause, really, on Jackscript. I'm not abandoning the project. So I'll explain. So I've realized, and this is after a lot of thought, I've realized that I need to take a little step back and just document the things that I'm learning, right? So you might be thinking, okay, what do you mean? Why do you need to take a pause in order for you to document what you're learning? Just pull up the readme.md and just document everything that you need to document, and then continue on working with Jackscript, right? So I learn a little bit differently, right? I don't want to say I'm a little bit slower than other people, but my brain isn't as fast as I would like it to be. So since I just learned something new, I like to document it. So how I operate is that I work with cheat sheets, right? I usually have a lot of cheat sheets, or I create a gang cheat sheet. So just type gang right there. So I'm just gonna say GitHub. Get wow. This is my my GitHub. So I have a bunch of cheat sheets. I don't know if this will show up. So I have a CPP Python. This is a C++ cheat sheet. I actually need to change the name to CPP cheat sheet. It started off as a CPP Python cheat sheet and C as well, but I just changed that. It's just now CPP, as you can see here. I have a Qt cheat sheet. I have a JavaScript cheat sheet. I have a React cheat sheet. I have a V cheat sheet. I have a CSS cheat sheet, assembly. I just have cheat sheets for any little thing that I feel as though there's just a lot of information that I'm probably gonna forget if I don't create a cheat sheet for it. So that's why. I also have, if I go to my Google Docs, right, I document a lot of the things that I learn. Some things I keep in repositories, and some things I keep in cheat sheets like this. So this is a Docker cheat sheet that I created years ago, but I keep updating it whenever I learn something new in Docker. So as you can see, it's just a bunch of commands right here, right? So, and I have yeah, I have a lot of these cheat sheets. So in addition to all of these, I also created a blog. My personal website has a blog, right? My blog consists of me basically explaining things to other people. So if I learn something, I also create a blog post about it, explaining it. Me explaining it reinforces my learning, and it also helps other people as well to learn from what I learned and to learn from my mistakes in the past. So with that being said, this that I've just gone through now, learning about what is this, TypeScript, and how all these things work, and how not JavaScript, but creating a type of coordinate is not, or a tuple is not the same thing as a array, what is it called, array literal. And the fact that for me to make a comparison between this new type that I've created, or tuple, in comparison to an array, literal, and how these things work together, or how they don't work together, or how they're not the same thing, It's just something that I feel that I've learned and I should probably document somewhere. For me, that's just very important. And if I can't do that, and I can't do that because I don't have a blog, right? So let me explain. My blog got, I don't know what happened to my blog. So when I'm at home, I use a desktop computer. When I'm anywhere else in the universe, I use my laptop. And I make commits with my laptop, I make commits with my desktop, and maybe one day I made a commit with my desktop and then I used my laptop somewhere. And when I was trying to, merge the code or something got broken. I don't know if it ended up going to a previous commit or deleting the other one or what happened. But now essentially what's happening with my blog is that this is my blog, right? This is my personal website. It's on Versal. It's on Versal currently. So there's no blog here because I removed it because it doesn't work, right? And if I go to the blog link, it's a 404. The blog doesn't work, but it used to work. So it doesn't work because it got taken down, and it got taken down because there's something wrong with it essentially. So there's just pieces of code missing, and I need to get this thing up first so that I can create a blog post about the thing that I've just learned in TypeScript, so that I can continue with my Jackscript library creation. And before I do that, before I work on this blog, I really can't work on Jackscript because I'm gonna forget most of the things that I write, and I don't want to do that. Okay, this won't take me too long to build on my blog. It won't take me too long to rebuild because the code is still there. If you go to my 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 GitHub, I don't know, where's my repository? Here, the new Daniel. That's public also. Oh no, it's private actually. I have the blog somewhere here. Let me just see. App. Where's my blog? Oh no, it's in previous repositories. Sorry, not previous repositories. In previous commits. It's in previous commits, somewhere in previous commits. It's somewhere there. I need to extract it back up and upload it. So here it is. This is a repository. This is my blog. You see, it's just a simple page, but it has a lot of content inside. So I need to get that up, and then once I get that up, I'm gonna get my Jackscript library back up. I'm gonna wrap it up. As a matter of fact, I'm gonna probably work on them simultaneously. So, but what I will document in the next video is probably me working on my blog post or my blog website. In fact, I'm not sure, but most probably you'll see me working on my blog website and getting that up and running. And the same time, I'll be working on Jackscript on the side. And I'm just saying, don't be surprised when you see both of them running at the same time. So okay, and what I'm gonna do for now is I will most definitely um, release a new version, which will be a version, I don't know what version, but it'll be a stable version. I'm just gonna create tests on the I'm gonna write tests for some of these in fact for all of these functions: the intersects, the union, domain, range, is subset of, and is okay, yes, is subset of, and is superset of. And then I'm gonna ignore these ones for now. And then also the Cartesian, the create Cartesian method, I'm also gonna write tests. So I'm just gonna write a whole lot of tests here for these methods, and then I'm gonna release it as a version 1.0.0 stable. And that means that the documentation will also be updated on npm, because like I said, this is old documentation. So I'll have a new version. And the reason, guys, I'm doing this is because what motivated me to work on this library to begin with is because I was getting weekly downloads. People actually downloading this thing. I mean, I know it's like 1 or 2 or 3 or 0, sometimes 0 weekly. Is it weekly downloads? Yes, weekly downloads. this week I got like 20 weekly downloads, which is absolutely absurd to me. And it might look like I was the one who downloaded this library. It was not me. When I came back and started working on this library, I found 20 weekly downloads that same week that I started working on this library. And then this week it's down to 0. And I've been working on this library for the entire for 2 weeks now, basically. So yes, I found a lot of motivation working on this library because people are actually downloading this thing. So people are actually trying it out, and they probably use it, they probably download it or whatever, and then they start using it or installing it and using it, and then they realize that, oh no, this actually, it doesn't work, and then they get rid of it, right? So I feel like I owe people a library, so I will definitely work on this. So that's my plan right now. Build my blog so that I can upload in all these updates that I'm learning, or everything that I'm learning, and then simultaneously work on Jackscript. And then yeah, maybe after a week or two, everything should be up and running. So that'll be Code Vlogs video 3. This is video 2. Yeah, so now what I'm gonna do is I'm gonna explain that I have learned right now, and why I'm unable to actually continue on with this library. So as you know, I was working on the is reflexive method and is irreflexive. So I'm just gonna is reflexive and is irreflexive. As you can see, it's just the method that takes in a Jackscript set and returns a boolean, right? So what I was doing is in here, and I hope you guys can see. So in here, this is just like my test file, right, called Romeo.ts. So I have, just ignore this for now, I have a set here, set A, which is a Jackscript set of a number, and let me think, and then no, let's see, okay, we have n set A, which is a Jackscript set of a number, right? And n set A has these elements inside of it, and then we have my array, which is an array of coordinates, right? Just ignore this for now, right? Which is an array of coordinates 1 1 2 2 3 6 6. In theory, right, according to set theory, this is a reflexive relation on set n set A. So this array is reflexive on this. That's just the math, that's just the theory. Now if I actually test this and actually run my array on this set, it actually returns false. And here's the code, is reflexive. This code works, it's code that works, it makes sense theoretically, but it doesn't work in TypeScript. You can't have this function or method do what you wanted to do or test for reflexive being reflexive. I can't speak properly. It won't work because and I had to do a whole lot of digging for me to realize this. But because this, as you can see, this array is of type coordinate number, but this is not the same as, or this, since it's a coordinate number, it's still an array literal. It's not the same as what's this thing? It's not the same as this. So this is not the same as this, although it looks like it's the same thing. This is an array that takes in coordinate number, so it takes in the type of a tuple, right? And it goes in here. It's not the same as me creating separately a tuple here. This is basically regarded as an array literal, and this is not. This is a tuple, this is an array literal. I am not sure what would have happened had I created maybe this variable and then I have this array that is empty, and then I started inserting all these variables inside of this array. I don't know what will happen. I don't know if it'll be like, okay, yes, now this is a tuple and this is an array of tuples, and now we could say that this is equals to this. I'm not sure if that will be the case, but even then it's still a risk, because probably the users of the library will probably do something like this and, you know, run it, basically do what I'm doing here, you know, run this and try and test for reflexivity or any other method, and will be surprised when they get problems or inconsistent results. So what I'm going to do is I'm going to make sure that not only for me, but only for users of the library, I'm going to make sure that they get consistent results throughout. So I asked an LLM and it came up with this. Well, it didn't just come up with this function. It explained why I would use this function. It's basically testing each and every single element inside of the array. So it's basically testing this one and this one and checking if those are indeed the same thing. And if they are, of course, it return true, etc. And it'll just do this for, so okay, so if I use this function, this will now be equal to this, is essentially what I'm saying, right? So with that being said, I need to go back and try and really understand exactly what's going on here. I do understand it, but I want to document it so that I never get to forget it, right? So basically that's what's going on. And yeah, so for now, what I'll do throughout is I'll just update the documentation. I'll delete all unnecessary code that I have. These properties of relation methods, I'll just comment them out, and then I'll just package up I'll also write the test case, or sorry, the unit test for all these methods that I've created, and then I'll package the library up, and then I'll release it as a version 1.0. So it means that the version maybe 1.2 or 1.1 will include the properties of relations tested. And yeah, that's basically it. So guys, this has been Code Vlogs episode 2, and I cannot wait until episode 3 comes out. I will see you guys when I see you guys. Peace, man. Thank you for watching. Like and subscribe.